Property 3. Normal curves are symmetric with scores more concentrated in the middle than in the tails. Okay? A very famous rule about this property. A very famous rule reflects this property is the 68, 95, 99.7 rule. Okay? This rule reflects this very important property of a normal curve. But before I introduce you what is the 68, 95, 99.7 rule, I need to introduce you a notation first, okay? And we're going to use the notation from now on to the end of the semester. Now, suppose I give you a density curve, and the variable of interest is x. And this is a density curve. As you can see, the curve is right skewed. It's not symmetric. So this is not a normal curve. But why I mention this? Well, that means my notation can also apply to any density curve, not just normal curve. If I tell you this point here is A, and this point here is B, then the shady area above interval AB, but under the curve, this shady area. What is the meaning of this shady area? Okay? Now, the shady area. It has two different interpretations. It has two different interpretations. First one is a percentage or percent. The percent of observation. The percent of observation whose x value are in the interval A to B. The percent of observation whose x value are in interval AB. A second interpretation is the probability of selecting x from interval AB. Okay? Two different interpretations. And the first one, the percent of observation whose x value are in A to B. Okay? This is from the data point of view. And second one, the probability of selecting X from interval AB. This is from the probability point of view. It's from the probability point of view. And doesn't matter it's from data point of view or from probability point of view. As you can see, data point of view, we refer to percent of observation. From probability point of view, we refer to probability. Doesn't matter it's from data point of view or from probability point of view. We're going to denote by notation P. This P can refer to percent of observation or refer to probability. Okay? That X is between A and B. Okay? So let's go over this one very quickly. Okay? The shady area in any density curve. Okay? The shady area, it has two different interpretations. From data point of view, is a percent of observation whose X value are in A to B interval. Okay? And the other interpretation is a probability of selecting what? X from interval AB. So the notation we use, we say this is probability or percent that X value are between A and B. Okay? Next one, property 4. No, I still not finished property 3 yet. Okay? With this notation, we can talk about the 68, 95, 99.7 rule. Okay? Now let's look at the rule. The 68, 95, 99.7 rule. The 68, 99, and 99.7 rule. Say this is a variable interest. And this is a normal curve, okay? Now, the center of the normal curve is mu. And here is an inflection point. So this is mu plus sigma. This is mu minus sigma. And how big is the area? How big is this shady area? Well, we denote it by probability that X between mu plus sigma, but greater or equal to mu minus sigma. This is roughly equal to 68%. Okay? That's why we see 68 here. Okay? Let me repeat. Within 1 sigma around the center mu, cover about 68% of observation. Okay? Now, if you check the table, if you use standard normal table, you're going to find the actual probability is 68.27%, which is very close to 68%. And also, 68% is very close to 2/3. That's why you hear people say, within 1 sigma around the center mu, cover about what? 2/3 of observation. Okay? And next one. When X greater or equal to 2 minus mu minus 2 sigma, but less or equal to mu plus 2 sigma, is roughly equal to 95%. Okay? And the actual probability is what? 95.44%. Okay? 95.44%. That is within 2 sigma around the center mu, cover about 95% of observation. Now, next one. Probability that x less or equal to mu plus 3 sigma greater equal to mu minus 3 sigma. This one cover about 99.7%. Okay? So let's look at the graph here. Okay? Suppose this is mu plus 2 sigma. This is mu minus 2 sigma. And furthermore, this is mu plus 3 sigma. And this is mu minus 3 sigma. So, in the red shady area, how big is the red shady area? Okay? It's 99.7%. That means if a data set really follows normal distribution, within 3 sigma around the center mu, cover 99.7%. Okay? If you check with the table, you will find this is 99.74%. And what do you know about 99.74%? It's almost 100%. And what does that mean? That means 3 sigma an observation. How likely an observation deviate from the center by more than 3 sigma? It's almost what? Unlikely. Okay? Because from here to here, cover nearly 100%. That means the black shady area here. Okay? Any observation here is what? Deviate from the center by more than 3 sigma. How likely is that? Is the area is close to what? 0%. That means almost what? Impossible. Okay? Same thing for this side. The area is nearly what? Area is nearly 0%. So if a data set really follows normal distribution, you expect to see nearly 100% of observation located within 3 sigma around the center. Okay? Now, any observation that deviate from the center by more than 3 sigma in the normal distribution is unlikely. Okay? Say I have 100 observation. I expect to see no observation deviate from the center by more than 3 sigma. If I have, say, 1,000 observation, I expect to see about what? 2.6 observation. They deviate from the center mu by more than 3 sigma. Okay? Now, last one. If I have a data size of 10,000, okay? I only expect what? 26 of them fall in the area like here, okay? I only expect what? About 26 observation that deviate from the center by more than 3 sigma, okay? By more than 3 sigma. In simple language, if the data set really come from a normal distribution, you can what? Hardly find what? Any outlier. Okay? That's what we say. And the 6895, okay? This is wrong. 6895, 99.7 rule, okay? Is a very important feature for normal distribution, okay?